Hello, good day, good evening, good morning, whatever time of the day it is. Welcome to another screencast. This one is, I'm going to safely say, the most important screencast of this unit. It is the particles, and how do the particles of matter explain the behaviors of mixtures? Let's waste no time. There is, back in grade 7, you covered the particle model of matter. And this theory attempts to explain how individual molecules or individual atoms of matter will react and behave in our everyday lives and everyday situations. There are 4 basic points to this theory. They are spam.
Spam, even spam.
More spam.
Glorious spam!
Oh, okay, so that may not have made a lot of sense to somebody who doesn't know our context, but it will in a second. Principle number 1 is actually this. Particles have space between each one of them. Solids have small spaces, liquids have slightly larger spaces between, and gases have even larger spaces between. So as we change the state of matter, the space between each particle changes size. The analogy that I might give with this is this jar of marbles. If I fill this jar of marbles, the marbles, although they fill the jar, don't completely fill the jar. Okay, think of the marbles representing maybe a solid. A jar full of marbles still has space between each single marble. They don't physically fill everything. So I am able to add more substances to the jar. This would be just the same as adding sugar to warm water. As I add sugar to the warm water, the sugar actually fills the space between each one of the different particles. Point number 2. All matter is made up of tiny particles, and different substances are made up of different particles. Easy enough. This is sugar. Okay, we see sugar as the picture on the left. Chemists see sugar as the picture on the right, as its individual particles. Point number 3. Particles of matter may be attracted or bonded to one another.
The name is Bond. James Bond.
No, not that kind of bond. What I meant was that because there is slight charges, positive, negative charges on some molecules or some atoms, they have an attraction towards opposite charges. You can see this actually with water. If you turn on your tap, just a thin stream of water, and you take like a balloon or a brush and you rub it through your hair, and you hold it close to the stream of water, you'll actually see the water bend towards the comb. That's because the water has one charge and the comb has another, and there's an attraction there. Okay. Last point: the tiny particles of matter are always moving, and they're vibrating. They are almost always never at rest. Okay? So in solids, the particles are wriggling kind of in one place. They're moving, but not really. In liquids, the particles are sliding around over each other, still moving a little more freely, but vibrating. And in gases, the particles are moving very fast and have a lot of space between them. Okay. Think of as we speak, right? The sound waves traveling through the air. That's because the particles are vibrating as they travel through the air, and those vibrations in the air is what your ear picks up. Okay, so those particles need to be moving in order for us to be able to hear. So why did I want you to remember to spam?
Glorious spam!
Well, spam stands for spaces, particles, attracted or attractions, and movement. Spam. Spam. Okay, so we have this. Hopefully this acronym will help you remember what it means. Now, different particles have different sizes. Okay, so keep this in mind. Keep spam in mind. Particles have different sizes. So when we mix substances, the smaller particles of one substance will actually fill in between the spaces. Yes, the space between, in between the spaces of the larger particles of the other substance. So, for example, when we take Kool-Aid and we add it to water, the juice crystals of the Kool-Aid also they're attracted to the water particles, but they slip in between the spaces of the water and they quote unquote dissolve. Okay? They sort of disappear from the water. There's actually two properties of the particle model of matter, that there's an attraction and then they fill in the spaces. And that's how we get things to dissolve into our water. Okay? If we want to change the rate of dissolving, we want to change how well something dissolves, or how fast something dissolves. That's better. How fast something dissolves. We can do three things. One, change the temperature. If you increase the temperature, you increase the particle movement, which means more particles moving around, larger spaces, things can fill in between. Number two, we can change the size of what we're dissolving. For example, if I try and dissolve a sugar cube versus a teaspoon of sugar, the teaspoon of sugar will dissolve faster because it has a larger surface area and the particles are more spread out and smaller. The sugar cube has a small surface area, and it takes a lot for all the water particles to interact with every individual sugar cube particle because they're all packed together. And lastly, we can stir. Stirring moves all the particles around, which creates more bumping of particles. Okay? And the bumping of the particles allows more interaction, allows more opportunity for attraction to happen, and more opportunity for particles to fill in the spaces. Okay? So to sum everything up, SPAM. We have spaces. We have everything has particles. There are attractions, and there is movement. Hopefully that acronym and everything we've talked about here will help you remember the 4 points of the particle model of matter. From here on out, everything that we do refers back to what the particles are doing. So you have to be able to understand this principle. Okay? Awesome. Thanks for watching.